present problem number 13, Moire thread counter. My name is Loman, and the problem formulation goes as follows. When a pattern of closely spaced non-intersecting lines with transparent gaps in between is overlaid on a piece of woven fabric, characteristic Moire fringes may be observed. We're supposed to design an overlay that allows us to measure the thread count of the fabrics, determine the accuracy of simple fabrics, for example linen, and then investigate if the method is reliable for more complex fabrics. So now to start, I would just like to point your attention towards this picture here. As seen on this man's suit, we have these characteristic Moire fringes, and this is the way that they usually look in the context of everyday scenarios. However, in this presentation, we will go into more how we can artificially or within a controlled setting achieve these Moire fringes and what we can actually use them for in order to measure certain properties of threads and the fabrics. So just some underlines here. We want to design an overlay and measure the thread counts of different fabrics. We want to investigate this if the method is reliable. So first, for a brief explanation of the actual phenomenon. These Moire fringes can easily be obtained when you have two patterns here of parallel lines. And the crucial thing about these two patterns displayed is that they have different spacings. The distance in between each line is different for both of them. So what happens if we put them on top of each other, as shown here, we see some dark areas and some brighter areas, and these dark areas are what we call Moire fringes. Now, as displayed by the arrow, we will move one of the patterns towards the right, and now you see how the fringes move towards the left. So let's just go on for a while, have here displayed what actually are the Moire fringes. Now, this phenomenon can actually also be observed in linear patterns that are angled against each other with a small angle. As seen on the visualization here, when the patterns are closely angled to each other, you see these dark areas up here, and those are also these Moire fringes which we are talking about. Now, why do we see this? And why does the human eye recognize these dark patterns when lines are put on top of each other? Well, in order to further explain this for you all, I would like to take into consideration the superposition properties of two patterns on top of each other. So, as seen here, I'm going to visualize this with sine waves. And these sine waves have a different frequency. And as seen, the two patterns of lines on top of the sine waves correspond to actual lines in a Moire frequency, in a Moire pattern. Now, if we take and put in this blue, that is the first sine wave minus the other one, and when we squish it together, we see this. So these would be the Moire fringes explained with a more superposition point of view. So now, onto the relevant parameters in this problem. In theory, when we just have lines, we can talk about it as the thickness of the lines, the space in between the lines, and maybe most crucially for this particular phenomenon, the line frequency. In practice, for actual fabrics, this translates into the thickness of the threads, and then of course the airspace in between the threads, and then something which is called thread count. And this is very crucial, because thread count is what you measure the quality of different fabrics in, and is usually given in the unit lines per inch. So now, onto a theoretical model. We start off by considering this equality. Now here we have D, capital D, which is the distance between two dark areas, or also called these Moire fringes. Then we have D1, which is the spacing in between two lines in one of the patterns, and D2, which is the spacing in between the others, in the other fabric. Now we recognize that if the lines start in sync, we then say that for the larger larger distance between the lines, it will take k of these distances, and k plus 1 distances of the other line spacing in order to reach another another situation where they are aligned. So this gives us the distance between the black fringes. Then we move along here down through the equations a little bit, and we arrive at this case d2 over d1 minus d2. And then we take this and put it into our original equation, or equality, and we derive this model for the fringes. Now, this problem stated that we should make some overlay. And here we have a picture of the overlay which was made. And what's important about this overlay is that we decided to have a 6 to 7 relationship between what was black and what was transparent. And this was because it was sufficient for the application. We also verified the thread count, or to say thread count of the model using a MATLAB script with the shown accuracy here. And one thing to note throughout the remaining part of my presentation is this method was used to verify all thread counts which we're discussing today. So now, this theory prediction. Well, if you take into account this equation, you see that large differences between D1 and T2 will result in frequent Moire fringes, while a small difference would mean the opposite. That means that D1 has to be roughly equivalent to D2 for the phenomena to be observed within a particular range. We moved on and made a theory simulation here. And here we have V1 as a varied parameter, D2 is constant, and D is measured. And what we basically plot here with the red line is the expected value, and the dots are some measured points which were made, including error bars with a 95% confidence interval. And here we see that the model fits very well, and that it can be used. So for the first experiment, we wanted to investigate parallel lines. So we took photographs from above of a fabric, which then we put the overlay on top of, and we had a light source underneath to amplify the phenomenon. This gave us these results. Here you can see we used two fabrics here. For the first fabric, which is displayed on the top left, we had quite a good fit, and for the second one, the fit was not as well, and this probably is due to some sort of standardized error in the measurements. We have here displayed the accuracy, and I would like to point out that we managed to achieve a 1.4 with some standard error percentage accuracy for one of the fabrics, which I would deem pretty accurate for real-life application. Secondly, we decided to look at what happens when fabrics are tilted against each other. And for this, we use this formula, where the T1 and T2, as displayed in the picture, are the distances in between lines or threads. They are equal to each other for our experiments, and we'll get to that in a bit. And Tm, of course, is the distance in between Moire fringes. Now, this theory predicts, as you can see, that the fringe density, or the distance between fringes, will be proportional to the actual thread count of the fabric. And we made some additional notes that the apparent darkness of the pattern which we create will depend on the thread count and the thread thickness. We also observed in our pilot studies that the angle of tilt between the two fabrics should be less than 10 degrees, otherwise the phenomena will not appear. So what we did was we took a photograph of a fabric, as you see this is a very zoomed in picture, and we analyzed it. We converted it into grayscale and put it into a program called Adobe Illustrator. We then made a replica. So we had the first fabric here, we made a replica, and we tilted it 1.64 degrees. So here you can see that tilting these two pictures against each other achieves this phenomenon of fringes in both directions. What we then did was we measured the distance in between these fringes. And we measured across the whole picture, and we took many different measurements in order to reduce errors. And we found that this. So we did this experiment for 4 different fabrics, and as you can see, the accuracy varies in between these different fabrics, depending on these the fabric's properties. Or I would like to point out that the phenomenon description has also a rather good accuracy with regard to real-world application. If you actually wanted to measure threads, this would, in my opinion, be sufficient enough accuracy to get good data. So now, in conclusion, from our first experiment, we used a linear method, and it could be used to determine the thread count of a fabric within 1.41% accuracy. And I would like to point out that if you actually were to measure a thread count of a fabric in like the real world, say you're a tailor, you're buying fabrics, this would actually be a sufficient enough method to measure within a good accuracy. In the second experiment, we found that it was useful to determine the thread count for some fabrics, and we draw the conclusion that the accuracy depends on the fabric's characteristics, and the thread count affects the shape of the Moire pattern. I can show an example of this if we have time. I would also like to point out that we have a comparison here with accuracy between the linear and the angular method, and for this the linear turned out to be more accurate and probably also more easy to use for real-world applications. So I would recommend that one. So finally, for the task fulfillment, we did design an overlay. We determined the accuracy for this particular overlay, and we did also investigate some more complex patterns as asked for in the problem formulation. Thank you very much for your attention.
Question from opponent.
Okay. Well, what was the range of your overlay? So, how many threads? From how many to how many threads it counts?
The thread count of the overlay varied 5% plus or minus to the thread count of the fabric we investigated.
Oh, so your overlay allowed you to count every possible thread count. So if it was like 1,000.
Well, if the thread count was 1,000 lines per inch, we would have to use overlay with a similar thread count to that fabric, as stated here, because otherwise the fringes would not be observable. It would either be too small a distance between them or too large a distance.
Okay, thank you. So in which fabrics was in which types of fabric was the measurement more inaccurate?
Well, the largest inaccuracy which we found was actually for a fabric called chiffon, and that is a fabric commonly used in light scarves. Now, we theorized that the reason this was so inaccurate is because
thank you. And so, you think that for every chiffon fabric, we could find a formula that would allow us to compute the actual count from our measured count?
Well, so the thing about the chiffon in particular is that the threads in that kind of fabric are so loosely tied together that they might move, and that it might actually have different thread counts throughout the fabric. And I would very much like to discuss this with you later.
Okay, thank you. What's the unit of measurement for the thread count? Could you please tell that again?
For this, to keep it simple for this, all the things we did, we used the unit lines per inch, which is also the standard unit for this within the textile industry.
Okay, so I've got more time.
Yes, a little bit.
Maybe. Was everything you found within range? So you're sure that every measurement you made was the actual? Well, okay.
Maybe you can do it during this session.
Okay, so I would like to thank the reporter for the nice presentation. There are some things that we especially like. There are some minor, maybe inaccuracies, so I would like to address these points in my presentation, but I think there's a problem.
There's a technical issue.
But the time is counting. Maybe you can
The time is
do
counting,
it
so
without couple
please-
5%.
okay. So please, there is a problem with our computer, so we can project it on the screen.
Can you read it for us?
There is a problem that's frozen right now. It's not working, as you can see.
Okay, so maybe I will do that without the presentation. Okay, so I don't remember the exact definition, but I will move on to the pros and cons of the presentation. So I liked very much that he used some mathematical formulas to show us how Moire fringes are created, and he also used sine waves to illustrate how humans perceive Moire fringes and why the eye perceives it like that. He talked about the importance of the proper alignment, so he talked about the angles that we must use. He included footage of his experiment. I think that's all of the pros, and then from the cons he didn't cover some points of the theory well. There are some things that we can consider, such as okay, so I will talk about them in the discussion. I think the overlay that the team used wasn't the most convenient method they could use. There is an overlay that would allow us to have more flexibility and to do less measurements. Another pro is that they included percentages for their accuracy, but they didn't explain us very comprehensively how the actual and the measured thread count are related. So for those, for example, for the seafoam, he gave me an answer in the clarifying questions, but he could have included this description in the presentation as well as for the other fabrics. Something there, I might summarize. I think I summarized. And also something about the range. Maybe we shouldn't be so careful about the range of the thread fabrics, given that we can use some other methods that I would like to discuss with you about. And another con is that there were some minor mistakes. For example, thread count in fabric industry is usually counted in threads per square inch. So it's the width and the warp, and not just one line of fabrics. So now I would like to invite the reporter to discuss with me. Please.
Thank you.
Okay, so could you please draw a simple picture of your overlay and tell me what you see to measure the thread count?
Okay, so the overlay is a very simple concept here. We can imagine we have a sheet of transparent paper here, and on this very sheet we printed out parallel lines with equal distance to each other. So those are the properties of the overlay, basically.
Okay, and so when you put that on the fabric,
Correct.
and you expected to see the Moire fringe that is created and then compute the thread count.
Yes.
So how did you know what the distance between those lines should be? Because you said that the range of your overlay should depend should be close to the actual range of
Yes.
thread count. So how did you measure?
So first of all, in the beginning, when you're designing these overlays, you of course don't really know what the thread count of the actual fabric is. And as I stated, you have to be somewhat close to the actual thread count in order to see the phenomenon. So in the beginning, it was a lot of trial and error for finding which thread. I use the term thread count for the overlay, even though there are no threads, but I think it simplifies the conversation. So what we then decided to do that we made this method of verifying thread counts with this script that I talked about,
Okay.
which in essence, what that script does is it takes a picture of the thread of the fabric itself and counts the threads, and then we can design a sufficient overlay in order to see the phenomenon.
Okay, thank you. Can I have the marker,
Of
please?
course.
So you measured that there were a lot of trials, a lot of errors, and that you used another equipment to design a proper overlay for fabric. So I would like to discuss.
What other equipment do you mean?
The computer. That's,
Yes. Oh, okay.
So I would like to propose another design of the overlay so that you don't have to do all this thing. So instead of using parallel lines, we could use converging lines. So they start like that.
Yes.
Of course, the design is not good. I can
No,
draw
but
it with a marker, but
To get what you mean that the lines are tighter on this end and then go towards being more spread out.
exactly. And so we can okay. So we can know how much the distance between those points
Yes,
is,
of course.
and we can know how much the distance between those points is.
Yes.
And because could you go to a slide with the mathematical with the formulas KD? So it included KD. Have you understood what I'm? Yeah. So there you are. If the distance is very close, so the
Yes.
Moire fringe will be very big, right?
Very big, yes.
So at
That's
some
very large.
point in our overlay,
Yes.
the Moire fringe will be a black line from the top to the bottom. So with that overlay, we could just find the right.
Not necessarily. In the beginning of our work, we discussed using this type of overlay. Now, one problem with that is to get printer to print it out accurately, which we discovered. And another would be that you would have to use an entirely different equation, but because what we of course here are interested in is the distance, or what we measure actually, what can be measured about these Moire fringes is the distance in between them. So then maybe you could propose how to calculate that.
Well, I'm not sure that I've understood your point, but we know the distance, so we don't have to compute anything. We don't have to
So the
use
distance-
any other equations. It's just so you've got the D2, which is the actual distance between the lines of the fabric. Say that this is the fabric, and you have the D1, which is changing. Here it is different. Here it is different. Here it is different, and you just find those points where it is right.
In essence, that is what we have done. We have just used different fabrics of equally spaced lines, and I'm sure that this method could also have been used. But I would like to point out that the basic mechanism behind both methods is in essence the same, and what is important is the applicability of it.
Yeah, I
the
cannot
use.
deny that. I'm just talking about.
So then we are in
So
agreement with this. Thank you.
So there is no mistake. Experiment or set up, just that it's hard. So I would like to state my discontentment. Maybe I think that K plus 1 would be wrong. Can you draw an example so you what my thought is?
All right. So the basis behind this is a very simple mathematical derivation. What we have is one pattern that's like this, let's say, with some length in between. Let's call this D1.
Okay.
And then we have another pattern with a slightly smaller distance in between each line. And here you see it takes 5 of these lines and 6 of these lines in order to reach for the line to sync up. So that's the explanation
Yes,
behind
but
it.
can I have a marker? So I agree with that. So in that case, it's K. This is K, and this is K plus 1, right?
Yes,
But
amount of distance is needed.
yeah. So imagine that we have this line, this pattern. Imagine that we have a pattern 5 times more frequent. So 1, 2, 3, 4, 5. 1, 2, 1,
Yeah,
2,
I get what you mean.
5. You see here, it's K. K is 1 or 3. But here it's not K plus 1. It's like K plus 3. So I would say that the formula needs K plus N, where N can be any number, and it doesn't change the final thing because it will be
Well-
D equals N
Well,
D1.
what we're interested in is the distance between two fringes.
Mhm.
And that appears when we have these conditions which are displayed.
Yeah.
I don't really see
sure.
the point of using a k plus n because we're
Well-
actually only interested in what happens when the lines are in sync, and then they go slightly out of sync, completely out of sync, and they resync again. And that
Yeah.
is what the distance between, in essence, a period of the Moire fringe pattern.
Yeah, well, I agree, and it won't produce a different result because you have d equals n d1 to d1 minus d2, and the denominator is the under part of the fraction. I think the word is right. So the under part of the fraction is what causes the phenomenon. So we don't care about what is on the upper part of the fraction. But I'm just talking about mathematical.
But we are in agreement, yes, that
Yes, we
that-
are.
the method of calculating these distances is correct.
Yeah, sure, there
No
was no
problem there.
mistake. It's just that I would improve this equation so that it's fully correct and that it does not just produce the right results. Could you, I'm interested in how you define the relationship between actual and the measured thread count, and not in the sequence, maybe in some other fabrics. Could you draw an example of the measured thread count and the actual thread count? Where did the difference come from?
Okay, so I think it's easier if I show this on my results graph here. So here, the blue dots here represent what we have verified to be the actual value of the thread count in our fabrics. Of course, with a slight 0.67% uncertainty reference of the reference value, which is to be neglected in this case, I would say. Now, the uncertainties here, or the accuracy rather, is just taking how close we got to the actual value in essence.
Well, okay, can you give me please a marker? Well, I do that, and the truth is I really appreciate those graphs because they are very clear. But what I would personally be interested in is the reason behind these differences. So, for example, I'm aware of the Oxford cloth design, which involves this is what we would accept, the warps and the wefts. So we would like to measure this distance.
Yes.
But in the Oxford cloth, the most prominent lines are the diagonals because of the way it is woven. So the overlay we use will just count the most prominent lines, which are these ones.
Well, okay. So
we
this,
can
in my opinion, comes down to being able to actually get the phenomena to appear before our eyes. So if you were to put the like if you tilt it like slightly like this, the most prominent Moire fringes would be those from these two. If you put the overlay like this, the fringes would occur from the lines that are in the same direction.
so
Now
in
you
the
do-
horizontal direction.
Yeah, if you put the lines of the overlay in the horizontal, you would get fringes actually in vertical.
Okay, so because
Or
our
in the
time is
horizontal,
finishing,
yeah.
I would like to make a finishing remark. I don't think it would be the horizontal and vertical components because then we wouldn't have a large deviation. I think the proof that this is what happens is that we have a large deviation in Oxford cloth.
Converging math, you're saying, or like,
I
so we
think
have to start at the clock.
No, I concluding remark for our discussion. That's what I meant.
This is your time.
Yeah, you're right. We had a nice discussion. I actually liked the design of the experiments that the Swedish team had, and it really produced some good results, and they had some good graphs, but there were some inaccuracies. Maybe in mathematical equations they didn't alter the actual results, but they were not good. And also I propose a different overlay, different experimental setup, so that we don't have to do all this procedure to produce the same results. I think that although they did a really good work at giving us some details about the numbers, they should have shown us some things about the geometrical relationship and maybe define a formula to compute the accuracy, to maybe compute the actual type form, the measured without further analysis.
Thank you. Question from the reviewer.
Yes, to the reporter.
Yes.
Hi, so, how do complex fabrics differ from simple fabrics?
As pointed out here in our discussion, one of the characteristics of a more complex fabric would, for example, be lines not just in the horizontal and diagonal direction. Another thing which I would consider to be crucial for a complex fabric is actually really dense lines. Those are harder to
Okay,
measure.
that's thank you. So, what do you think cause the limitations on complex fabrics and your ability to measure them? Why
The
can't
fundamental limitation for complex fabrics is getting the phenomena to occur at all. This has to do with the complex fabrics often not letting through enough light to be able to see the dark areas and the light areas, which goes back to my superposition argument.
if you put your overlay onto complex fabric, you would not see a pattern?
Well, it depends. If you put a very strong light source behind it,
Yes.
behind a complex fabric, you might. We have
And
not.
why would this pattern be wrong after putting a strong light source behind it?
Excuse me.
Why would there still be deviations after you put the light source
Well,
behind
it wouldn't necessarily be deviations. It would, or do you mean the phenomena in deviation? Well, it has to do with you have to have enough light coming from behind to be able to distinguish
If
between
it
dark.
was,
Then it would just work as normal,
it
but
would work as normal.
yes.
Okay. What would happen if I took my pattern? Oh, this is to both of you. If I took my pattern on fabric and I rotated it. Yeah.
We have shown this. If you had a pattern of the same thread count as the fabric.
Different thread count and different angles as your
Yes. Okay. Then you would have the two phenomena occurring at the same time, and you would get a different angle of the fringes created, and you would need a more complex formula to near calculate.
For example, with this overlay, the improper alignment would cause a very strange shape. So there are more fringes that go like that, like cross.
So I thought you were assuming that the overlay had constant
Yeah,
thread count.
constant parallel alignment.
Okay, then I remain to my answer.
Okay.
Yeah, but can I add something? Even if it was with a constant, with the same distance, then if we wouldn't have the proper alignment, there would be some curves, not straight lines.
Okay, yeah. Thank you. To the reporter, can you quantitatively model the shift in angle and the shift in the frequency of the Moire fringes, given the relative parameters?
In theory, yes. In practice, it has turned out to be a bit more difficult with.
Is it
Okay, time is over.
It is what we've shown in the angle example.
Hello, my name is Clark Lee. I am from Team Canada, and I will be reviewing problem number 13, Moire thread counter. So we are all familiar with the problem statement, so let's move on. There are a couple of tasks we first define in order to solve this problem. The first task is to qualitatively describe the formation of simple Moire fringes. You have to understand how they form and why they form. After that, we can theoretically predict certain fringes for simple patterns in our fabrics using mathematical models as stated. And next, we can physically construct an overlay for more complex fabrics using this understanding of the simple phenomena. And then we can experimentally verify this for the more complex fabrics by varying parameters such as the angle of tilt and the frequency of the lines in different fabrics. So summary of the report. We believe that Sweden has a limited solution for this problem. First things first, they qualitatively explained how simple Moire fringes occur, and they also extended the theory for angle patterns. They also provided experimental confirmation for simple pattern overlays, and they also have a thread counter for angle patterns as well. So to the reporter, you have a couple good things. I like how you have a very thorough qualitative explanation of your Moire patterns, and you have a very clear experimental procedure. But what you could probably do better is you have a very limited theoretical model. There's no theoretical model right now for true complex fabrics where you have secondary patterns forming on the pattern in those diagonal lines, for example, like two on the board. The model is limited to parallel and angled pairs of lines, but it doesn't account for multiple layers in more complex fabrics that are layered on top of each other. And also the thickness of the threads themselves are neglected in your account. Also, you have a limited experimental account. So you have little explanations for the deviations in your more complex fabrics. You simply stated that they are not as effective, but you do not really explain why they are not as effective. What really goes wrong? And so, also, I think you have misinterpreted the purpose of your thread counter. To my understanding, you have multiple overlays of the same frequency. And so if I give you a random piece of cloth and you want to measure the thread count of that, you would have to sift through each one. The problem statement clearly asks for a simple overlay that you can just put over one piece of fabric and not have to try multiple combinations. Now for the opponent, you had a summary on the report and you look at the equations for simple fabrics, but I believe that you lack flexibility and convenience in your thread counters as well. You also provided suggestions for other thread counters, and I believe that you rightly clarified the definition of thread count and brought up more convenient and flexible overlays. But also, I believe you lacked prioritization in your questions, and you didn't provide enough suggestions for the reporter. Now on to our discussion of our analysis of our discussion. So you proposed alternate thread counters. You said that more flexible overlays would could be used for converging lines. So the reporter said it would be difficult to print precisely. We partially agree with the opponent. Converging lines require only one overlay with less measurements, while the MATLAB solution that Team Sweden used does not satisfy the problem statement's requirements. Next, you also talked about the determination of Oxford thread counts. You said that thread count cannot be simplified into horizontal and vertical components. And the reporter said that the primary pattern can be clearly identified. We disagree with the reporter. The pattern from several parallel rays are superimposed and must be considered uniquely. You also missed a couple points. You missed the methods used to.
Okay. So thanks to both the reviewer and the opponent for this discussion and for the points brought up. So now on the converging lines method, which was brought up by the opponent, I would argue that our method fits just as well and is in essence the same thing, just printed out over multiple overlays. And the perk of these multiple overlays is that it's more easy to measure. How the accuracy was determined for our methods is quite easy. We just took the value for the thread count of the verified fabric. We took that, subtracted that with the thing which we measured, took the absolute value and divided by the actual the verified thread count. So that gave us a percentage accuracy. Speaking further on accuracy and error bars, we would like to just clarify that in order to account for discrepancies within fabrics and so on, we made sure to do 10 measurements of different intervals of Moire fringes, which were created on these with the overlay and the fabric. So this was to take into account that the thread count might be varied throughout the fabric and also for other measurement errors. So I would like to summarize that I think we have met the problem description. We have designed overlays, we have determined their accuracy, and we did manage to get them to work for Oxford cloths. Thank you very much.
Question from Gerald.
Question about your results. So how do you calculate your experimental error?
My experimental error is just based on the 95% confidence interval within the measurements that we're taking.
So the verified value, did you actually measure the value yourself?
Yes, in essence, that was what was done. It was done through taking a picture of it and then analyzing it with a common MATLAB script with a very low inaccuracy.
Can I just clarify your technique for actually measuring the thread count?
Yes.
You've got several different overlays. Given an unknown thread count, how are you using these overlays to determine?
You put the fabric on the table, and then you take overlay with a known thread count and put it on top. Then, if you see no fringes, that is most likely due to the overlay having too large difference in its thread count. So we had to experiment and later verify in order to know which thread counts were the overlays used. And then, if you see the phenomena appear, then you can make measurements.
So do you make measurements on more than one? It will not just be you get a clear phenomena on none at all.
You mean more than one fabric?
Well, no, one fabric, you're
Yeah.
using more than one thing.
Yeah,
You're
but
not going to just see it on one.
no, like as the equations describe, when you know the thread count of the overlay, and then you measure out the distances of the Moire fringes produced by that overlay, then you can solve for the unknown thread count.
So are you using the results from the different overlays that show some sort of interference patterns?
In essence, yes.
And how are you comparing them?
The overlays.
No, you've worked out with an overlay,
Yeah.
and you've gone, this is a pattern, I can see it, I've measured it.
Yeah.
Slightly different one, you will also see a pattern.
Yeah. But that pattern would have a different distance in between the dark areas.
So how are you combining those to get the sure one of what is the best value? What is the best value for your thread?
Well, you combine measurements done with different overlays. I think we have that shown here. Here we have used overlays of varying on the x-axis. We have the overlay thread counts. So we have used varied overlay thread counts on the same fabric, and they all give the same results at least for one basis.
Yeah, but here on your slide, the red line is even not within the error bars.
Yes, and this is due to some systematic measurement error. But I would still like to point out that the accuracy is quite, like, if you imagine you're gonna determine the thread count of some unknown fabric, then getting it within 5%, I would say, is for many real-world applications so good enough. For instance.
So again, given some unknown, for example, Oxford cloth,
Yes.
which method would you use?
I would use this first method.
Actually, like in some experiment, is this like?
No, because the problem with this method is when you have, for example, an Oxford cloth,
Yeah.
it is so dense that it doesn't let
So
through
would it
enough
work
light.
or no?
So no, this method did not work with the
So
Oxford cloth.
you're
However,
saying that you would use it, but it doesn't work.
well, I would prefer to use it if I could get the phenomena to appear. Otherwise, I would use the method which I actually did use.
Any other question? All right, thank you.